Hi guys, Lever here from Bright Young Brains. In this video, I will be going through the 2025 May-June supplementary exam that was written not so long ago from now. And similar to the previous paper that I uploaded on this channel, I think it's best that we start from the bottom and work our way upwards, because that's where the slightly more difficult questions are. So let me scroll straight down to question number 11. Funny enough, yesterday I had actually attempted to start with this paper. Question 11 proved to be a bit difficult, so I left the whole paper this morning, woke up and attempting the paper again. So as you can see, I already went through question 11.1. Now I can imagine all we need now is an explanation as to how I got to the answer 152. So let me just remove everything. If you can figure out the answer from just pausing and looking at what I wrote down, that's perfectly fine. You can then just move on to question 11.2. But let me start off by explaining question 11.1. 11.1 asked the following, right? They said, consider the three-digit numbers from 501 up to 999. So if you're going to consider those numbers, they then asked how many of these three-digit numbers have exactly 15 in them. So this was the question at hand. This is the type of a question where you would want to work it out bit by bit, as you saw from the numbers and workings that I just erased. So the train of thought behind this type of a question is as follows. The first thing you want to remember is that all three-digit numbers between 501 up until 999, those three-digit numbers, you have numbers that start with the 5, right? And then you have numbers that start with the 6, start with the 7, start with the 8, numbers that start with the 9. So let's start off with numbers that start with the 5, right? All the numbers that start with the 5, there's only one option for this slot over here, which is going to be a 5. Now, the moment a 5 is placed over here, all these other numbers cannot be 5s, you see. So out of all the digits that we have, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 10 options, right? But if we put a 5 here, it means that we cannot use a 5 anywhere else within this three-digit number. So the number of options we have here, we only have 9 options. And it also means the number of options here, we also only have 9 options. We have to be careful though, because in this instance, we're starting from 501. We're not necessarily starting exactly at 500. So what we need to be careful of is that out of all these options here, right, numbers that start with a 5, and we exclude a 5 here, we exclude a 5 here. We know that this is a total of 81 options. However, we have to subtract the number 500 because it's not between 501 up until 999. So this is giving us an option of 80 in total. 80 options in total for numbers that start with the 5. Numbers that start with the 5 that only have 1 5 in them, you have 80 of those numbers. So, excuse me, having to have done that, you move on to 6. Numbers that start with the 6, right? We have to consider this first scenario. So if they start with the 6, it means that in this position, you only have one option. Now, the moment you put a 6 here, numbers that exactly have 1 5, you could think of a scenario where the 5 is over here. So meaning there will be an option of having 1 6 here, obviously, because we're talking about numbers that start with a 6. And then all the numbers that have a 5 here, we need to consider that there's only one option for this slot, right? So all the numbers that have exactly 1 5, it means that they will have started with the 6, the 5 would have followed, and then since we have a 5 here, we only have 9 options for this slot over here, because in this slot, we're not going to consider all 10 options. We're only going to consider 9 of them. So the only 9 options here. However, in a scenario like this one, we also then have to consider a scenario where the 5 is over here. You see, numbers that start with the 6, the 5 could possibly be in the last position. So in a situation like that, it means that there's only one option for the digit in the beginning, one option for the digit at the end. So the moment these two are there, in the middle, we only have 9 options, because 9 options here, we're trying to only consider numbers that are not a 5, you see. So in essence, it means that numbers that start with a 6 that only have exactly 1 5, you're going to have 9 options, right? Plus another 9 options, you see. So 9 options that start with 6 and 5, and then 9 options that also start with a 6 and end with a 5, you see. So 9 plus 9, that gives us a total of 18 options, you see. So that's one thing we need to consider. So for the 7, the 8, and the 9, fortunately, after we have explained the 6, you can easily see how all the others have a similar way of working them out, you see. So for example, numbers that start with a 7, right? We know that 7 can be in the first position over here, meaning there's only one option for that starting position. And then if the 5 is over here, it means there's only one option there, obviously. And then what we know is that the last digit, so from there, we know that in this last option here, we have 9 possible numbers that we can put there. Then it also then shows us that just like numbers that start with a 6, right? You have an option where your numbers start with a 7, yes? So it means there's only one option for the start here. And then numbers that start, or the numbers that end with the 5, that will be only one option for this slot. And then here in the middle, we have 9 options, you see. Then the process begins again, you see. 9 values in total that start with the 7 and follow with the 5. And then we add numbers that start with the 7 and end with the 5. You see, in total, those are 9 plus 9 values, which is 18. Numbers that start with the 8 and numbers that start with the 9, it's the same idea. You see, we will have 18 in total, and then we'll also have 18 in total. Ones that start with the 9, and ones that start with the 8. Excuse me. We will also have the same scenario, right? Where some start with the 9 and end with the 5. Some start with the 9 and the 5 is directly after. In this case, it's 8 and then 5 directly after. Or you have a case where it is 8 and then the 5 is at the end. Here we know it's a case where 9 is in the beginning and then 5 is at the end. So these are the total number of options that end or start with the 5, or whichever way. These are all the numbers that have exactly 1 5 in them. You see, then if you add this up, this is where I got the 152. So the logic behind this question is quite interesting. with other types of questions like these, we normally are able to just have one neat calculation and then we're done. But clearly not in this case, which is okay. So moving on to 11.2, it says, calculate the probability of a 3-digit number not satisfying the condition given in question 11.1. So this is quite straightforward. So if you read nicely, calculate the probability of a 3-digit number not satisfying the condition given. So all the numbers that satisfy the condition given, we know it's a total of 9, it's a total of 152 numbers. So the probability of numbers not satisfying that condition, we need to consider between 501 up until 999. How many numbers do we actually have all together first? Because once we know all the numbers we have all together, we know that that will be our denominator. Our numerator will be all the numbers that don't satisfy this condition, which will be our total minus the 152. That will give us all the numbers that don't satisfy the condition. So let's work out the total first of all numbers between 501 up until 999. So this one is quite straightforward because all those numbers between 501 up until 599, we need to think to ourselves, logically speaking, right? Since we're considering numbers that only start with a 5 up until numbers that start with a 9, we technically have numbers that start with a 5, 6, 7, 8, or 9. So it means in this position, we have 5 options. You see? And then in this position, we technically have all 10 options. And then in this position, we also technically have all 10 options. So in total, we have 10 times 10, which is 100, times 5, which is 500. However, we need to be careful to subtract 1. The one we are subtracting is the number 500. You see, because when we say 5 options in this first position, and then here we have 10 options, which is any number between 0 and 9. And then here we have 10 options, which is any number between 0 and 9. Within this total of 500 values, we have included the number 500, you see, of which 500 is not between these two. So we have to remove that one number that is included within this calculation. So what we know is we have a total of 499 values in total. The numbers that don't satisfy the condition, right, those will technically be 499 minus 152. 499, right, minus 152, that is giving us a total of 347. So we know that the probability of a 3-digit number not satisfying the condition given in 11.1 is going to be 347 over 499. Obviously, 347 over 499, it does look as though that's a number in its simplest form, you see. So that will be the probability that you're going to write. If you want to write it as a fraction, this will be approximately 0.6954, you see. So that's your answer. Since I've just gone through question 11, clearly you can see I'm going to be working my way backwards. So the next question is question number 10. Question number 10, right? Question number 10 says, A and B are mutually exclusive events. If the probability of A is equal to 42 and the probability of A or B is equal to 0.79. Calculate the probability of B. This is as straightforward as a question gets because the probability of A or B, according to your formula sheet, it is equal to the probability of A plus the probability of B minus the probability of A and B. You see? So one thing we need to be careful of is that mutually exclusive events, it means that the probability of A and B is equal to 0. That's mutually exclusive events. You see, for independent events, the probability of A times the probability of B is equal to the probability of A and B. You see, that's for independent events. This is for mutually exclusive events. So fine, for mutually exclusive events, in this calculation, we're looking for probability of A, the probability of B, right? That's what we're looking for. We have been given this value, we have been given this value. And logically, we have this value because we know this value is a 0 because these are mutually exclusive events. So to calculate the probability of B, we're going to put a value here, which we have been given, 0.79. Probability of A, that's 0.42. This is what we're looking for. If we put everything on one side, it's technically going to be 0.79 minus 0.42. This is the probability of B, right? That's our answer. Nothing more to it. Okay, so question number 10.2. So as of this recording, this is ideally the first slightly challenging question. It says here, a game at a fun park requires a player to roll a 6-sided dice and pick a card from a deck of 52 cards. Okay, the player wins if an odd number appears on the uppermost face of the dice, and the player also draws a picture card from the deck. Okay, a deck of cards has 4 suits: hearts, diamonds, spades, and clubs. There are 4 picture cards: king, queen, jack, and ace in each suit. So picture cards, that's technically 4 times 4, which is 16. And then it says a player pays 10 rand to play a game in an hour. 260 people can each play one game. If the owner wants to make 70% profit per hour, calculate the maximum amount that the owner must pay out to each winner. Okay, so honestly speaking, fortunately, this is towards the end of the exam, right? So depending on if you would have, answered all the questions that you can easily answer, then you can tackle this. So from the get-go, right, you do want to obviously read this again while making more notes. So the first thing is they said, if a game at a fun park requires a player to roll a 6-sided dice and pick up a card from a deck of 52 cards, right? For you to win, so let's take note of this. For you to win, 2 things have to happen. The first thing is for you to win, you win if an odd number appears on the dice. So odd numbers, we have 1, 3, and 5. So for you to win, it's a 3 out of 6 chances for the cards, and then 3 out of 6 chances for the dice, and then for the cards, for you to win, you have to pick a picture card. So there's 16 picture cards out of 52. So for you to win the first one and to win the second one, these are the odds, right? But then for you to then win the game, you see, for you to win the game, you have to get a odd number and you have to draw a picture card. So the odds of you winning are actually this half multiplied by the 16 over 52. You see. So that means the odds of you winning, it's actually 2 out of 13. So before we worry too much about the cost and all that, it means that the people that will win, it's technically 2 out of 3 of the 260. So this means that out of the 260, we're going to have a total of 40 winners. You see, so having to have broken that down, we firstly calculated the odds of winning, and then now we calculated how many people are likely to win. So the odds of winning, we can use that to get us the probability of, or rather we can get the number of people that can possibly win. So there's a total of about 40 people that can win based on the odds of winning, right? So with all that being done, they said a player pays 10 rand to play a game in an hour. 260 people can each play one game. So meaning that per game, the owner of this game park, let's see here. So per game, let's say here total revenue. So total revenue is going to be 10 people or 10 rand times 260 people. This is 260, oh no, 2,600 rand. That's the total revenue that they get. They say it here, if the owner wants to make 70% profit per hour, calculate the maximum amount that the owner must pay out to each winner. So what you need to remember is that if we're thinking of profit here, we may want to consider the following. So if your revenue is 2,600, in its simplest form, right? Revenue in this sense is just going to be the profit plus, for lack of a better word, let's say expense. So this 260 that you're getting, right? It is this 2,600, right? It's all your profits plus whatever you spent, right, to host all these people. So what you want to recognize is they said that the profit, they want it to be 70%. So it means that your profit is equal to 70% of whatever you are spending to make all this happen. So for the sake of a calculation, let's make expense X, right? So let's do it like this. Let me just do this here. I need to save space, you see. So we can say here, let expense equal to X, right? It means that your profit will be equal to 70% of X, which is 70 over 100 times X, which is 70X over 100. This is just 0.7X. So this is what profit is. You see, profit is 0.7X, and then expense, we say that's just X. So this will help us in our calculations, you see, because what we know is that 2,600 is equal to the profit plus the expense. You see, that's the formula we're using. Revenue is equal to profit plus our expense. So the reason we did this is, remember, if you're going to use a formula and there are too many things that are in the formula, like too many variables, try to always have a common variable so that you don't have yourself working with multiple variables unnecessarily. So this being done, let's see the question again, right? They said the owner wants to make 70% profit per hour. Calculate the maximum amount that the owner must pay to each winner. So the expense is the monies that he has to pay to the winners, technically, you see. This here we can say pay winners and so forth. You see. So the amount he has to pay winners, we have to divide that by 40 to see what's the maximum he can give a person. So working this out, we're going to have 1.7x 2,600. Divide both sides by 1.7. Let's see what this is giving us in the calculator. 2,600 divided by 1.7. This is giving us 1,500 and what's that number? 29.41. So the idea is the 40 people, right? So we can say therefore 152, or let me actually use a number that's not rounded off. So we can say therefore this amount here, we have to divide it by 40 winners. This is giving us 34 or 38.24. And let me put an arrow here to show that this is the final answer. So I do suggest that you look at this video again so that you get the idea and the logic behind what we did, you see. Otherwise, this is the logic behind this question. It's all a matter of remembering that your revenue, which is the 2,600, it's your profit plus the expense, which is the amount you're going to pay to winners. They say it's 70% of that amount you're going to pay to winners. They want it to be your profit, you see. So we just made that amount X. So our profit is just 70% of that, you see. So the 70% plus the amount we're paying out, this is the revenue we're getting, the 2,600 in total. So we worked out this is all the amount you're paying out to the winners, because I mean that's the money that is going out. The rest is supposed to be your profit, you see. So that's that for this question. Let's move on to the next one. Question number 9. Question number 9 is clearly a calculus question. Well, we're looking at a cubic expression here. It says, show that, or it says, given this expression, it's a cubic function. They said when it is factorized, it is equal to x minus 4, x minus k squared. Show that k is equal to 1 for only 2 marks. Okay, that's very interesting. So with this kind of a question, right, what you need to be careful of is the fact that firstly, basic knowledge will tell you that this is a cubic function that starts by going up, down, and then up again. Another thing is that you have 2 brackets here that are identical, right? X minus k, x minus k. And then this is an individual bracket. So these 2 brackets that look the same, it's telling you that you have 2. It means that you have a turning point where you also have an x-intercept. You see, I'll repeat, this tells you that you have a turning point where you also have a turning point. So this could easily be a scenario where your x-axis is maybe somewhere here, right? And then maybe your y-axis is anywhere else, you see. So this is where your x-axis could be. Or you could have a scenario where your x-axis is there, you see, where your graph ideally maybe something like this, right? Where you have y-axis here and then x-axis over there. So this is the scenario that we could easily be thinking of when we are trying to visualize this graph. The reason why I've chosen this format is because firstly, this is telling us that our y-intercept is a -4, right? This is telling us our graph starts by going up, down, and then up again. This is telling us that we have an x-intercept where we also have a turning point, you see. So this being x minus 4, this is easily telling us that we have a positive 4 over here. And then from this, we're getting this x intercept over there. So realistically speaking, k is a negative number, because if you put a negative here, this will be a positive, meaning on our image, it should be on the negative side of the x-axis. But then here they're saying that k is a 1, you see, so that makes things very different. We could think that maybe our y-axis could be somewhere there, right? Where if our y-axis is somewhere there, it means that this could still be a -4. And then here, this is a +5. And then obviously this would be a +1. So this image makes the best sense, you see. So all that being said, it was just background information to help us easily work out this 2-mark question. So all we would do is, if you expand this the way we have, if you multiply out the brackets and you compare the two equations, let's multiply out the brackets. X times x gives us x squared, x times -k gives us -xk, and then -4 times x gives us -4x, -x times -k gives us a +4k. So this is the two brackets multiplied together. The third one, we haven't multiplied it as yet. So if you multiply this third bracket with all these, we can say x times x squared, which is going to be x cubed. And then we're going to say x times -xk, that's going to be -x squared k. Then we're going to say x times this value is going to be -4x squared. And then x times this value is going to be +4x k. And then ideally, we have to multiply the k as well with everything else. So the -k would multiply with that, and then would multiply with this, multiply with that, and multiply with that. See? So in doing that, let's see what we end up with. You see? So let me just put this somewhere where we can easily write. So here, we maybe use a darker blue. -k times x squared is going to give us -x squared k. And here we're going to get -xk squared. And then we are going to get here a +4xk or 4kx. I would say ideally let's write the k first, because that's more of a constant. Let me just write this answer here. So we were at k times negative 4x. This will give us a positive 4kx. And then for the last one, we have negative 4k squared. So in this case, we only need like terms, you see. So when we say we only need like terms to work together, what I'm trying to say is, firstly, all the values that have x squared go together, all the values that have x alone go together, and then lastly, all the values that don't have x will go together. So in other words, the only value that does not have x is this one. To fast track the process, this number here, right, is the only number that does not have x. So it means that this value here is being represented by negative 4. So what we know is that negative 4 is equal to negative 4k squared. Divide both sides by negative 4. We are going to get here k squared is equal to 1. Obviously, if you square root a number, you're going to have plus or minus the answer. You see. However, in this case, we know that k has to be a positive. So we're going to say, therefore, k is equal to positive 1. Okay, so the next question here is question 9.2. It says the following. Calculate the coordinates of the turning points of f. So getting the coordinates of f is pretty straightforward because already, and getting any turning point of any graph, all we need to do is to differentiate the equation that we have and then equate that equation that has been differentiated to 0. So the reason we differentiate and equate our equation to 0 is because our differentiated equation is a gradient equation, you see. So us differentiating this f of x here, right, what we're doing is we are getting a gradient equation. This gradient equation, we're making it equal to 0 because we want to find out the x values where the gradient is a 0. The x values where the gradient is a 0 are x values of the turning point, you see. So with all this being done, all we're trying to do is to find the x values of the turning point, because once we find the x values of the turning point, we can throw those x values into the original equation, and then we can work out the y values of the turning point. So here we have put in all our values into our quadratic formula, and we just need to use the quadratic formula to get the final answer here. Alternatively, we could have just divided by 3 here, right? Divide everything by 3 here, would have gotten 0 is equal to x squared minus 4x plus 3. And then factors of 3 that give us a 4 is just 3 and 1. And to get negative 4, it has to be negative 3 minus 1. And then this is easily telling us that x is equal to positive 3 or x is equal to positive 1, which makes sense. Because if you look at the image we were referring to, you see, the one x-intercept is a 4. So it makes sense that a turning point is at 3. And in this turning point, we already know it's at 1. So once we have the x values of the turning point, to get the y values, we have to just throw those into the original equation, into the equation of f of x. If you throw a 3 in there, we're going to have, let's see here, 3 cubed minus 6, 3 squared plus 9 with 3 here minus 4. And then the other y value. We're going to throw 1 there, cubed minus 6, 1 there, and then squared plus 1 there minus 4. This one, we already know that if the x value is a 1, the y value is a 0. We already know that, you see, because that's one of the turning points here. The x value is a 1, the y value is a 0. If you solve this, you'll also see that you get a 0 here, because this is 1, right? Minus 6, that's going to give you minus 5. Minus 5 plus 9, that's a positive 4. Positive 4 minus 4, that's a 0. So that one we already know. Here, this is 27. 27, let me just do things a bit easier for myself. Well, why am I even doing this mentally? You know, I should just put everything in the calculator and then we get an answer so that we don't waste time, you see. So this is going to be 9 times 9 times 6, right? That's like 54. This is 54. And then this one is 27. So technically we have 27 here. Right? And then we are subtract 50 and add 27 again. And then we're subtracting 4. So the turning point here is at negative 4. The y value there is negative 4 according to our answer, which is okay. You see, that is perfectly fine. So let's move on to the next question. But before we do move on, though, we have to specify properly that we have our two answers. So this is a coordinate, this is a coordinate. So if you want, you can just say therefore 1 and 0, and then 3 and negative 4. If you left it like this, fortunately, this is also showing that that's a coordinate. So that would still somewhat give you marks. The next question, let's see. Let's see what the next question here is asking us to do. They said for 2 marks actually. Describe the concavity of f at x is equal to negative 3. So that's quite interesting. Let's check where. Well, fortunately, this type of a question, right? If you have followed what we've been saying from the beginning, keeping in mind our image of our cubic function here, what we know is that negative 3 will be where x is a negative 3, right? That's definitely a point on the left side of our graph. So negative 3 will be like somewhere here, you see. So they're asking, what is the concavity here? Is it concaved up? Is it concaved down? And so forth. So fortunately, excuse me, all you have to do is you need to know what your image for your cubic graph looks like. So if your image looks like this, right, what you need to recognize is the fact that at your turning points here, right, your turning points split up concavity, you see? So where you have, let's say, like a frowning side here, this section is concave down. Where you have this smiling side here, up. You see, it's just as simple as that. So since we already know that the one turning point is at positive 1, the other one is at positive 4. Is it 1 and 4? Yeah, 1 and 3. Excuse me, it's 1 and 3. The one turning point is at 3, the other turning point is at 1. So negative 3 will be like somewhere this side, you see. So this side, the graph is definitely concaved down. So we can just say here, concave down. So let's move on. 9.4 says, draw the graph of f label all points, label all turning points and intersects with the axis. So this is very, very easy, you see, because we've drawn the graph of f already. We said this graph, it goes up, down, and then it goes up, down, and then it goes up again. You see, we said this is +1. We said that this is +3. We said that this is 3 coordinate -4. We said that this part, well, this is not necessarily to scale, so let me make this a bit to scale. Let's do that. This point here will be -4. So we just need one x-intercept here, which we do have. It's a +4. If you remember from our factorized expression here, right? Our factorized expression is showing that we have a 4 here, that's an x-intercept. So 4 easy marks here, and you see, if you know your work, it's not even taking 4 minutes because all the information we have it. You see, 1 coordinate 0 over here, that's a turning point. This is a turning point. This is x-intercept. This is a y-intercept. This is an x-intercept, and then we can just label this here y-axis, x-axis, and then we can just label this of x. 3 marks. So let's move on. 9.5 says the following, right? Calculate the maximum vertical distance between F and H for which x is between 1 and 3. If h of x is -2 multiplied by the first derivative of f. It's a 6-mark question. Well, this is not a straightforward 6-mark question, that's for sure. Because firstly, before we even do anything, let's just see what this equation of h is. 2 times the first derivative of f, right? The first derivative of f, we know that this is the first derivative of f. And then, let's see here, the first derivative of f, let us multiply it by 2. So let's just quickly correct the mistake that I made here. So from here, dividing by 6 means that we have -1 here, +4, and then -3 here. So you want to be careful to use the quadratic formula in a situation like this. You see, otherwise you're just going to go in circles. So after using the quadratic formula, your x values will be 1 or 3. So 1 and 3. So since this is a negative graph, what we can expect to see is an x-intercepted -18 somewhere here, and then it will like turn and then come back down. You see, so this is the type of a parabola we can expect to be looking at. The question said, calculate the maximum vertical distance between f and g between 1 and 3. So the maximum vertical distance, regardless of where the maximum distance is, what they're looking for is, for example, the distance from here to there, the highest possible one. So to get that value, what you do is, firstly, the equation of h is the one with the higher y value here. The equation of f has a lower y value between 1 and 3, right? So what you do is you need to create a distance formula for this line here. So that distance formula will be in terms of x. To get the distance formula, you're going to have to say the equation of h minus the equation of f. So with the equation of h, we are going to take this one here. You see, the -6x squared plus 24x minus 18, right? And then we're subtracting f of x. F of x, we know it's this whole equation over here. So let's just take that equation, copy it, paste it down here. So you can see why this is a 6-mark question. You see, Me having to have drawn the picture and all that, that's more like for added information. But realistically speaking, you can just dive into doing what we're doing now. So the distance formula here for the vertical distance, we can get it from this. This minus this, these are like terms, these are like terms, and clearly these are also like terms. There's no like term here for negative x cubed, so we can start there. This minus this gives us negative 12x squared. 24 plus 9, that's going to be a positive 33x. Negative 18 minus 4, right? That's like negative 22. There you go. So from here, this being the distance equation, to get the maximum distance, we're going to have to differentiate it and then equate it to 0. Differentiating this is what we have, negative 24x plus 33, making this equal to 0, and then solving for x. We're clearly just going to use the, what you may call, the quadratic formula. Minus b plus minus b squared minus 4ac, the whole thing over 2a, right? So this so far is quite straightforward. Our b value is negative 24 plus minus b squared. That's like negative 24 squared. I should write a bit better here. Negative 24 squared minus 4. Our a value is negative 3. And then your c value is 33. Yeah, over 2a. So putting all this into the calculator, obviously before I do so, I would want to double check that I have done everything correctly. And so far, everything looks fine. I don't see any errors as such. So I'm just putting everything into the calculator now so that I see if we're on the right track. So minus here, and then the b value is negative 24. So the first answer that we're getting, clearly a strange looking answer as expected, because we do have 33 and 24 and 3 and all that. So that may be a bit unsettling, definitely. So before we do carry on though, you would want to just take a moment to 100% verify that there is no funny business happening. So far, let's see here. Go back to where we wrote here. Equation, yeah, there is funny business, obviously. Goodness, excuse me, I apologize. I think making such a silly mistake is uncalled for, because, I mean, look, we're supposed to put brackets here. Very, very tacky mistake. So this would be negative 6x squared plus 24x minus 18 minus x cubed positive 6x squared negative 9x positive 4. So the mistake I made right now is something I always actually call people out on. So these two will cancel out each other. Negative x cubed, there's no like term there. 24 minus 9, that'll give us 13. No, 15 actually. Positive 15x, and then negative 18 plus 4 give you negative 12. Okay, and now what? Now this, we can maybe put this into the calculator and all that. But I am thinking to myself, factors of 12 that give a 15. Let's see, 1 and 12 does not, 2 and 6 don't, 3 and 4 don't. 5 is not a factor, and then 6. So this does need the quadratic formula again. Our a value in this instance is -1. No, my guy. Goodness, why do I keep making such silly mistakes? I feel like I'm so distracted. Excuse me, I apologize. I keep apologizing. Just do things the right way, guy. You won't have to apologize. So here we said 24 plus -9, right? That's going to give us positive 15x. Because 24 minus 9 gives us 15x. And then -18 plus 4 gives us -12. -14 actually. Oh. So from here, this equation of dx, we can differentiate it and then make it equal to 0. -3x squared plus 15. So solving for x here, we're going to say 0 is equal to -3x squared plus 15. We need to be careful here with what we do, you see. So we're going to take this to the other side. Yes, divide both sides by 3. Yes. This is going to give us x squared is equal to 5. This is where you need to be careful. If you're going to square root both of these sides, right? Your answer, you need to put x is equal to plus or minus 5, you see. So logically, that is not possible because, no, it is possible because square root of 5 is, if you check in your calculator, square root of 5 is the number, let's see what number it is. It's like 2 point something, you see. So obviously here we will need to be dealing with the positive square root of 5, you see. X is equal to the positive square root of 5. So that's the x value where you will have the maximum distance. So to calculate the maximum distance itself, you have to take your distance formula, put square root of 5 in there. The distance formula is this one, you see. Negative square root of 5 cubed plus 15 square root of 5, and then minus 14. So, okay, square root of 5 cubed, right? Square root of 5 cubed as a negative is what you're going to have in the front there. Let's see here. Just give me a moment. Let's see. Times -1. So putting this in the calculator, right? We're seeing what, let's see what we get here. Let's see what we get. Plus 15 square root of 5, close bracket, minus 14. This is giving us the answer 8.36. So that's an interesting answer, but that's what we're getting for this 6-mark question. Question number 8. Let's see what question number 8 is asking us to do. Question number 8 looks straightforward as usual because we have the first principles question as usual and then the rest. So let's see, determine f prime from first principles if it is given that f of x is equal to that expression. So this is pretty straightforward. So the first thing that you need to do is we have to remember the first principles formula, which is f of x is equal to f, what's the formula? fx plus h minus f of x. But before all this, I need to write lim. And you'll be thinking, does the lim come before the equals? or after lim h goes to 0. There we go. You can just verify that using the formula sheet. So the whole lim h goes to 0 part, we can just, carry it over until we're done. So ideally what you want to do is work out what fx plus h is. So it means in the equation of f, wherever you see x, you put x plus h there. You see? So this will give us x squared plus 2xh and then plus h squared minus 2. If you multiply out this bracket, you see, because without wasting time, but now I have to explain something I basically know, x times x would give us x squared, x times xh would give us xh, and then x times h again gives us another xh, and then h times h gives us h squared. So this is what's going to go here, which is just x squared plus 2xh plus h squared minus 4. And then you have to, if you subtract this and if you subtract f of x, you have to be careful here to put x squared and then plus 2. See? And then our a value here will be 1. No. What am I doing? This is supposed to be divided by h. What did I even write down? I keep making these silly mistakes. Hey, Ekasiamar. Been a while. But I mean, some things just die young, I mean, some things I had to forget. Anyways, from here, this should cancel something, unless there's a mistake somewhere. Ha, goodness. Yeah. So many small errors that are just popping up out of nowhere. This is how you know I'm definitely out of practice, which should also give you the idea that as long as you're out of practice with your maths, you will definitely have a hard time with a lot of questions. But as long as you're consistently studying and practicing and exercising, you'll be fine. So from here, we're going to take out h as a common factor. And then here, you're going to get 2x plus 1 once you do what? But something is wrong. Goodness. Yeah, this is becoming too much. So once 1h is left there, you're going to throw in 0 where that h is, and then your final answer you're going to have here 2x. I don't think many people even watched this question because it's just too straightforward, but if you did, I apologize for all the small little dumb errors. Just so unnecessary. Differentiating this, 3 times 2 gives us 6, and then differentiating this value gives us a 4, because 1 times -4 gives you -4, and then 1 minus 1 is 0. So here, since you've differentiated, this is your final answer. 8.2.2, this is the first derivative, right? They said, well, technically they want us to, what do they want us to? They want us to determine, okay. They want you to determine the first derivative if this is the original graph. So since this is the original graph, because we want to simplify it first, we can write g of x. This is the same as x to the power of a half. However, this is x minus 1, because it's squared, you see. So before we multiply inside, let's say x times x is x squared, x times x is negative x again, and then positive 1. And then, what now? If you multiply inside, you're going to have the negative 2x. If your bases are the same, so you add the exponent. This is going to be 5 over 2. Here, let's just look at this as like minus 2x. You know, it's going to make our life a bit easier. So multiplying inside here, you're going to have positive 4x. Your bases are the same, so you add the exponents. 1 plus a half, that's just 3 over 2. And then this, again, well, technically a negative and a plus gives a negative. There you go. So now that you've gotten everything, let's differentiate. This times 2, that gives us negative 5x. Yes, and then this times 4, that gives us 6x. Well, here I didn't remove 1 from the exponent. Goodness me. Goodness, man. Removing 1 from the exponent, here you have a half. This times this, you have negative 1. Removing 1 from the exponent, you have negative half. Whew. So this is fine. You're going to get your 4 marks for this. So I just need to double check that I didn't make any silly mistakes. This times this, that's fine. Removing 1 from the exponent. This times this, that's fine. Removing 1 from the exponent. This times this, that's fine. Removing 1 from the exponent. 8.3, right? Let's see. Given that y is equal to 4x minus 14. This is a common tangent to this graph and this graph. So two parabolas, they have a common tangent. Calculate the value of a and b for 6 marks. Tangent to graph questions are just very easy, you know, because first and foremost, the gradient of a tangent will always be the gradient of the curve. So what we now know is that this curve and this curve, they both have a gradient of positive 4 somewhere. So what we need is a coordinate where that gradient is a positive 4. Because so far we have a gradient of positive 4, we just don't know where that x value is. So let's get more information about where this gradient of positive 4 is. The reason why I'm focusing on the positive 4, it's because that's the first concrete piece of information that we have regarding this tangent, or this parabola rather, or regarding this question in general. So what we know is if you differentiate your f of x, you're going to get a gradient equation. So differentiating f of x, we have here 4x minus 4. That's the first derivative. If you make gradient of 4 here, we can now work out x, right? So this goes to the other side. That's like 8. Divide both sides by 4. And then this is a 2. So x is equal to positive 2, where the gradient is a 4. That's for this graph. So when they say it's a common tangent, we need to remember that it will touch both graphs at the same point. So since the x value of the gradient, where gradient is a 4, the x value is a 2, let's just figure out the y value. So in the original equation, where x is a 2, let's see what the y value is. See, so this is 4, 2 squared is 4, right? So let's see. Oh, goodness my. So this is, let's see what we have here. This is 4 times 2. This is 8 minus 8 minus 6. So minus 6 is the y value, where the x value is a 2. So that's fine. That's fine. Now we have a coordinate, 2 and negative 6. That's a coordinate where both graphs meet. That's a point where both graphs meet this common tangent, as they say. So what we now know is, let's see here. What we now know is the following. Let's check here. So let's see here. Let me see what we can do here. Give me one. So from now, since we have a coordinate that both graphs pass through, in the graph of G, since we're looking to get two variables, A and B, anytime you need to get two variables, you need to, the first way to get them is if you work them out simultaneously, meaning you need at least two equations, you see, two separate equations that can help you to work out those two values A and B. So the first equation, let's use the coordinate equation. So meaning let's put where y is, let's put -6. So let's do this. Where is this thing here? -6 in the equation of G, right? Well, we're working with the equation of G right now. So working with the equation of G, where y is, we're going to put a -6 there. Let's see here. Equal to A. Our x value is a 2 squared plus B. X value is a 2 minus 18. So this is going to be 4A plus 2B minus 18. Ideally here you can just maybe make B the subject of the formula since it has the smallest variable. Everything on one side, -6 plus 18. This would be positive 12, yes. And then minus 4A here. Just do this. Positive 12. Yes. And then minus 4A equal to 2B. There you go. Divide both sides by 2 here. You're going to have 6 minus 2A. And then you have B here. So this is one equation, right, that has A and B. Another equation is obviously going to be the gradient equation of G. Because the gradient equation of G, you have a gradient of 4. And you know that the gradient is a 4 where x is a 2. So the first derivative there would be 2ax plus b. You see, because here constant falls away. 1 times b is just a b. 1 minus 1 is a 0. In this first derivative, gradient is a 4. X value is a 2. So this is like 4a plus b. And then, excuse me, the 4a can go to the other side. 4 minus 4a, that's b. So you can just equate the 2. So this is 6 minus 2a equal to 4 minus 4a. Both sides on one side, that's negative 2a plus 4a. And this is like 4 minus 6, right? So negative 2 plus 4, that's like a positive 2. And then this is negative 2. So therefore, a here is a negative 1. So that's what we're getting for a. So obviously, if a is a negative 1, it means that our b value, this is 6 plus 4, which is equal to b, right? Therefore, b is equal to 10. Interest at a rate of 15% per annum compounded monthly. Calculate the annual effective interest rate of this investment. So your effective interest formula looks as follows. IFM, and it says plus 1 is equal to this is something I would say to just look at the better to just have your formula in mind before your exam starts, because it's not a formula that's on your formula sheet. So sometimes you have your formula with the y, just fine. I might as well just put it on the other side, so normal to look at. So with all the information we're given, this is what, hence why it's a 2-mark question. We're going to 15% there. So ideally you can put 0.15 over. So all this, you're just going to put in your calculator. Let's see what we have here. All this in the calculator. Going to have open bracket 1 plus fraction button, that's like 0.15 over 12, the whole thing to the power of 12 minus 1. This is giving us a total of, this is giving us 0.1608, and then rounded up to 2 decimal places is 16.08%. So that's okay, nothing too extravagant there. The next question is out of 5. It says Tino invests 500,000 in an account earning interest at the rate of 6% per annum, compounded quarterly. Okay, fine. So what else did they tell us? Compounded quarterly, and Tino decides to withdraw 11,250 at the end of every 3 months. Yeah, that's quarterly. Then he says, yet Tino will continue making these regular withdrawals until there's no money in the account. How many withdrawals of 11,250 will Tino be able to make? This is a straightforward question. However, for this type of a question, you need to be careful to use the P formula, present value annuities formula, because the P formula is the one where you are reducing this, even though it's withdrawals, the logic behind it is that you want to pretend that this is almost like a loan that's gaining interest every quarter. So as this money is gaining interest, you are reducing that balance by 11,250 every month. So what we need to keep in mind with a question like this is the following. P is 500,000. X is 11,250. Our interest is 5% per annum compounded quarterly. So that would mean 6% over 4. So that's all the values we need in this calculation. So how many withdrawals? It means you have to work out a value of n. So what you need to be careful of is that where you see n in our formula, we would put the 4 times the number of years. But anyways, before we do anything, let's just make n the subject of the formula. So to do that, we would multiply both sides by I. This is what we would have if you multiply both sides by I. And then divide both sides by x. There you go. And then let's take this whole thing here to one side so that it's a positive, and then take it to the other side. 1 minus pi over x. And then since we want to make n the subject of the formula, so if we do that, we're going to have log. The base of the exponent becomes the base of the log, and this value is still just there. So since we want to make n the subject of the formula, I think it just makes sense that we divide both sides by negative, and this negative is there, right? Put in our values, 1 plus 6% over 4, 1 minus 500,000 multiplied by 6% over 4, the whole thing over 11,250. So all this being done, we need to put everything in the calculator nicely. I'd actually made an error, so when I corrected it, I just put everything in the calculator now. The answer is 73.79. 73.79, right? However, just right better. So in this case, since this number is definitely, you know, way above 73, leaning more towards 74, you can say here, therefore, well, fortunately, even though the number is leaning towards 74, you would want to say, therefore, 73 withdrawals of 11,250, because the 0.079 here, the 0.79 here tells us that the last withdrawal will be less than 11,250. Moving on, it says, on 1 March 2021, Abby made a once-off deposit of 12,000 Rand into an account earning interest at a rate of 9.5% per annum compounded monthly. She deposited 500 into the same account on 1 April 2023 and continued to make these monthly deposits of 500 on the first of each month thereafter. Calculate how much money was in the account immediately after the deposit of 500. Immediately after a deposit of 500 is made on 1 March 2025, exactly 4 full years after initial deposit. Here you need to be careful because it looks as though she made a deposit in 2021, right, of 12,000. And then she let this amount sit for quite a few years. Well, not quite a few years, for just 2 years. It looks like just 2 years. And then afterwards, once that amount had accumulated to a certain value, she started making monthly installments until 2025. So this is somewhat straightforward because all we need to consider is the fact that initially she was making initially she made a deposit of an amount that was just going to gain interest. So that amount was 12,000. The interest was 9%, 9.5% per annum compounded monthly. And this was technically for 2 years. This is 2 times 12. So let's see how much this 12,000 accumulated to before she started making monthly installments, right? So this is 1 plus 9.5%. and then this is to the power of 24. So this is giving us 14,500.14 if you round it off to two decimal places. So this is how much she had, right, before she started making monthly installments. So when we're thinking of monthly installments, we immediately need to introduce the F formula. You see. So if we introduce the F formula, means that our X value is 500. Interest rate seems to have just stayed the same, 9% per annum compounded monthly. And then our value of N, we have to be careful here, right? Because obviously from 2023 until 2022, that's another 2 years. And then we can throw all that information in the formula. So F here will be equal to 500 Rand, 1 plus the interest rate, which is 9.5% over 12, the whole thing to the power of 24, minus 1, 9.5% over 12. Okay, let's see here what we get in the calculator. We're going to get we're having here 500, and then we have 1 plus 9.5% over 12, and then this is to the power of 24 minus 1, and then this is also 9.5% over 12 as the denominator. Final answer here is a bit oh, okay, here we have to be careful. Here we have to be very careful not to make a very bad mistake as I was about to make. So what we need to consider is the fact that the 500 and the 14,500, right? Logically speaking, right? This amount is gaining interest as well when these 500 rands are being made, or when these 500 rands are being deposited. So yeah, we have to be careful here. We have to be very careful. So with the 500 rands alone, right, these are accumulating to a total of 13,158.65. So that being said, right, this 14,514 over the 24 months also gaining interest. So let's see here, A is equal to P, 1 plus I to the power of N. P is 14,500, and then our interest is 9.5% over 12, the whole thing to the power of 24. See here, 24. And then let's see what this amount equates to 14,500.14 1 plus 9.5%, 12 whole thing to the power of 24. This is giving us 17,251.18. And then adding these up together, you're gonna have, let's see here, plus 13,158.65. 30,679.83. There you go. So very strange question, but not too complicated once you just work on it without overthinking it. So let's move on to the next question. Question number 6. It says here the graphs of f, which is clearly an exponential graph, and the graph of g, which is a straight line, are drawn below. A is 3 coordinate 4. They say here it is a point of intersection between f and g. You have b also here. B is the y-intercept of the exponential graph. Then it says E is the x-intercept of G. This looks like a straightforward functions question. Let's see what they're asking. For 4 marks, asking for P and Q, right? So essentially they're asking for the equation of the exponential graph. Since we have 2 variables in the standard form, ideally, you may just want to work those 2 variables out simultaneously. So the first thing that I would do is, clearly we have two coordinates that we can throw into this equation, right? There's 0 coordinate, -3, then there's 3 and 4. So one at a time, let's see. If you put -3 where y is, then you put x as 0, you automatically get q, because this is just 1 plus q. -3 minus 1, q is -4. Straightforward, no issues there. And then for p, we can just use this coordinate. We put 3 and 4 in the equation. So 4 where y is, and then at x we put 3, q we know that's -4. There you go. -4 plus 4, that's going to give you an 8. And then 2 to the power of 3 is what gives you an 8. So therefore, p is equal to 2. Easy marks, 4 marks. It didn't even take us 4 minutes for that question. Write down the range of f. Also straightforward, because as long as we know that the y value of the asymptote here is -4, we know that the range is everything above -4. So we can say here all the y values need to be bigger than -4. Not bigger or equal to, because the graph does not touch -4. But anyways, it says the graph of G, or rather the inverse of G, also passes through B, which we know B is the coordinate 0 and -3, right? 0 and -3. Determine the equation of G in the form y. So let's deal with the inverse of G, since we seem to have more information on that. Okay, so if you think of the inverse of G, right? What we know about it is 2 coordinates. There's B, and then remember, since this point is on the original graph of G, its inverse would have a point somewhere here, which would be 4 and 3. You see? So let's take into account those points, 4 and 3. So technically what that means is the gradient of the inverse, right? We can work it out by saying 3 minus negative 3, 4 minus 0. You see, this would give us 6 over 4, which would give us 3 over 2, right? That's the gradient. And then, what else? So this is the gradient of the inverse, right? Its y-intercept is clearly going to be negative 3 because B is a point on the y-axis. So therefore, the equation of the inverse, right? It is equal to 3 over 2x minus 3. Fine. So obviously, if you get the inverse of this, you get the equation of G. So here we can say x equals to y equals to x. If we swap x and y, we have x is here equal to 3 over 2y minus 3. And then you can take the 3 to the other side, right? X plus 3. 3 over 2 y. And then if you make y the subject of the formula, you will technically have 1 divided by 3 over 2, that's 2 over 3x. 3 divided by 3 over 2, that's a half. Yes. So here you can say therefore y is equal to 2 over 3x plus a half. So with what I've just done here, it's just a matter of using your calculator, you see, so that you don't find yourself, no, it's 2. Goodness, you see, I'm busy making a silly mistake here because I did not use the calculator. You see, so essentially all we did here was we divided by 3 over 2 on one side, 3 over 2 on the other side, you see. Or rather, we can even say individually, we divided by 3 over 2. Then this is the equation of y. They said we should get the equation in the form y. So the first 2 attempts, I was making silly mistakes. And on the third try, I just realized, let's just work with the inverse, get everything, and then we can just get the original graph. 6.4 says right on the equation of the inverse. That's strange. Well, I got the inverse first here, and then, very interesting. So I will just say, therefore, y is equal to, let's just write this down, 3 over 2x, and then minus 3. So it means that for 6.3, there's probably other ways of having to have worked it out, but I used whatever way I used. 2 marks, that should be enough. So let's move on to question number 5, since we're working backwards. Question number 5, more functions. I think by now you know that functions is just the bulk of your exam. So you see the graph of f of x, it's a parabola, excuse me, which is in completed square format. C is a coordinate, the turning point of f, and then B is the point on the graph. Fine. Then here it says that show that f of x is given by this equation. So the reason why I emphasized that it's in completed square format is so that you can see that we have P and Q. See, P is obviously going to be the opposite value here. Q is going to be 4 as is. So we have P and Q in the equation. Fortunately, we have a point that the graph passes through also. So we can put in something for P, something for Q, something for X, something for Y. So that we work out A, and then we multiply everything to get this format. So let's do it like that. You see, straightforward. We're going to say here, well, rewriting the equation seems appropriate, so that your examiner knows where you're subbing in all that information. But anyways, nonetheless, we say this is negative 4, x is negative 3, p is positive 1 because you put the opposite in the equation, and then q is positive 4. Simplifying this, negative 3 plus 1, that's positive, that's negative 2. Negative 2 squared, that's a 4. And then negative 4 minus 4, that's negative 8. Divide both sides by 4. That's gonna give us negative 2. Which makes sense because you see this is a frowning graph. So anyways, you're going to then say, therefore, in the equation of f of x, you know that you have negative 2 here. X is x. Q is 4. So let's multiply this out. Negative 2, x plus 1, x plus 1. You're going to have negative 2 here, x squared plus x plus another x plus 1. Whew. Negative 2 in front here. This is x squared plus 2x plus 1 plus 4. Multiply the negative 2 inside. This is what you have. And then if you simplify, just before we carry on, let's see, it's definitely going to give us what we have there. F of x, negative 2x squared minus 4x plus 2. These are all very easy questions. There have been 1 or 2 questions within the exam that have been difficult, but these are just very easy. Determine the values of k for which this equation will have no real roots. So this is just a shift. This is just a horizontal shift. So to simplify it even further, let's just say here f is moved up or down. So what they're saying is that f is moved up or down, right, to form a new graph. However, how many units up or down does it need to be moved so that it has no x intercepts? You see, because roots are intercepts. So there's an x-intercept there and x-intercept there. The only way it will not have any roots is if it's moved more than 4 units downwards. Because the moment it's moved exactly 4 units downwards, this is what the graph will look like, right? If you move it 4 units downwards. But the moment you move it more than 4 units downwards, it will not have any roots, you see. So the graph of f has to be moved more than 4 units, or rather, let's say k has to be smaller than 4, you see, because as long as k is smaller than 4, it means that the graph of f has been moved more than 4 units downwards. In that instance, it won't have any x-intercepts. Question 5.3, you can see here, I have previously attempted this question, but here we are. It says there, right, the graph of y is equal to it's the first derivative of g. They said it is obtained when f is reflected over the line y is equal to 4. Draw the sketch of g if where x is 0, the y value is below 0. So the y value is a negative. Indicate any stationary points on the graph. So the first place to start is obviously with the image that we have been given. So keeping in mind the image that we have been given, right? And if we just look at our question a bit more focused. If we're a bit more focused as we're looking at this question, right, we will see the following. So first and foremost, they said, we are seeing the image of f here, right? This is the image of f. They said the first derivative of g, right, is obtained when f is reflected over the line y is equal to 4. So the line y is equal to 4 is this line here. So it means the first derivative of g will be an image that looks like that. You see, this is the first derivative of g. They then said we should draw the graph of g. Remember, if the first derivative of g is a reflection of f, remember f is a parabola. You see, so logically, this first derivative of g is also a parabola. So if the first derivative of g is a parabola, it means that g of x is cubic. You see, because only when you differentiate a cubic graph do you get a parabola. So the obvious place to start is you'd be thinking, okay, how many marks is this question? It's a 4-mark question. If you're going to draw the cubic graph here, you have to remember that first and foremost, since our parabola here is a smiling parabola, it means that our cubic graph is also, somewhat a graph that starts by going up, down, and then up again. The only thing is, take note that this parabola does not have any x-intercepts. If this parabola does not have any x-intercepts, it means that our cubic graph does not necessarily have two distinct turning points like that, you see. So we have to be careful. We can already be thinking of an image that's a bit squiggly like this, you see. So keeping that in mind, what you can also remember is that our cubic graph, right? One piece of information that we can take away from our parabola is the point of inflection that we can work out. Remember, our point of inflection of our cubic graph, it will always be the second derivative equated to 0. You see, of which the second derivative equated to 0, looking at this image, our second derivative, if you make that equal to 0, you will be working out the x value of the turning point of the parabola. You see, so if we had to differentiate twice and equate to 0, we would be getting this x value here, which is -1. You see, the -1 is the x value of the turning point. It is also, let's say it is also the point of inflection. So remember, the point of inflection is where your graph will be changing from one state of concavity to another. So what we know is that the graph will change concavity here. So meaning if you have an image that looks like this, right? The point of inflection would be along this dotted green line. What we don't want to forget though is they said that in this graph of G that we're about to plot, we need to be careful that along the y-axis, right, the graph will cut the y-axis below 0. You see, they're telling us that if your x value is a 0 for the graph of G, the y value is going to be a value that is below 0. So what we know about our image is that firstly, our cubic graph is going to be a positive cubic graph. What we also know is that since it has no x-intercept, it's going to be somewhat almost like a curve that looks something like this, you see. So for us to have this curve on this image here, right, the only logical way to do it is, firstly, there's a point of inflection along this dotted line. So we can imagine that our graph goes up, does like a squiggly thing here. Well, let me maybe just start it from here. It'll be like somewhere here, somewhere here, somewhere here. And then somewhere here, it starts to curve going downwards. There you go. This is what our graph of G would look like. You see, this is what our graph of G would look like. There's a squiggly thing somewhere here. They said indicate points of indicate stationary points. So what we can do, we can just maybe label this -1. The exact value of the y value of the point of inflection, we technically cannot get that because we don't have the graph of G. We cannot work it out. That's integration. That's not within the scope of our grade of maths. But this is what the graph of G would look like. You see, there you go. This, I'd say level, it's an easily level 4 or 5 question. Before you finish an exam, there's no point trying to struggle with this type of question, but let's move on. The graph of F is a hyperbola. They said M is what? Where is this going to? What is this now? F is this, is drawn below. M is a point where the asymptotes of F intersect. Then it says C and D are the x and y intercepts respectively of F. A is a point on F that is closest to M. A is a point on F that is closest to M. So logically, that simple piece of information has just told you that you have a line of symmetry here. That line of symmetry passes through A. Because a line of symmetry of a hyperbola passes through the point where your asymptotes meet. And a line of symmetry of a hyperbola will always cut through the curve at a point that is closest to the point of intersection of the asymptotes. So that's very, very crucial information that has been given there. This coordinate is also given because of the standard form. Coordinates of M, I hadn't even seen they're going to ask that, but easy mark. 2 marks, easy. 4.2, calculate the coordinates of D. D is a y-intercept, so you have to make x as 0, right? So if you're going to make x as 0 in the equation of F, means that you're going to have y is equal to 4 and 0 minus 3 plus 4, right? And then it means that you're going to have 4 over 3 as a negative value. Then here y is equal to, let's see, negative 4 over 3 plus 4. Let's see here, plus 4. There you go. That's 8 over 3, right? 8 over 3. There you go, 2 marks. 4.3 says, if y is equal to this value, or if y is equal to this equation. Wait, did we even answer the question? No, we didn't. We partly answered it. D is 0 and 8 over 3. That's important to, to put out. Then it says here, if this is the equation of a straight line, if y is equal to this is the equation of a line of symmetry of F, calculate the value of T. Line of symmetry of F. So it's the one with the positive gradient. It doesn't even matter. Very straightforward question because you're just going to put in a coordinate that the graph passes through, of which we have that coordinate, right? It's just x value 3, y value 4. So T here is just going to be positive 1. And if you look at your image, yeah, it's possible. This could easily be may not be to scale right now, but if you look nicely, the line of symmetry may easily have an x value of 1 over there somewhere. This we know it's already above 1. So let's move on. Determine the values of x for which the graph of F is below 0. This is very straightforward. Determine the values of F, the values of x for which the y values of F are below or equal to 0. Just looking at the question again, it almost seems like they're offering too many marks for this question, but let's see. So we want values of f where it has x values that are below 0. So it looks like this is the part where you have x values that are below 0. But I keep asking myself, why is it a 4-mark question? Determine the values of x for which f of x is smaller or equal to 0. Yo. Well, it means let's get the x-intercept of the graph of f, meaning you make y as 0. Just looking at this question, just seems like they're being too generous. Like, honestly speaking, they're being way too generous here. But anyways, let's see. 4 over x minus 3, you can put this over 1. Then you can cross multiply x minus 3. And then you have minus 4x plus 12. And then you have positive 4x on one side. 12 minus 4 is 8 divided by 4 on both sides. You're going to have the divide by 4, x is equal to 2. Okay, does it make sense? Yes, it does. So between 2 and 3, right? That's the section where your graph of f has y values that are below 0. So you're going to say x is an element of positive 2 up until 3. You're going to include the positive 2 because the graph is equal to 0 at 2. And then you're going to exclude 3 because just before 3, the graph will still be having y values that are below 0. So for 4 marks, I guess that's fair. 2 marks for calculation, 2 marks for this. Not bad. 4.5, calculate the coordinates of A. A is a point of intersection between the line of symmetry and the graph of f. So, okay, let's work it out. How many marks is this question? 3. So, fine. The equation of f equal to the equation of y. Y is 4. And then this here, the equation of our line of symmetry, it was, yeah, x plus 1 here. Working out x first, let's take the 4 to the other side. You're going to have x minus 3. So the reason I did that is so that we can have a fraction. Then we can cross multiply. This would be x minus 3 squared and then 4. So what you can do, which is maybe unconventional, but still fine, you can just square root both sides, right? Then here you can put plus or minus 2 is equal to x minus 3. Then you can split your page in half. One side you use the positive 2. One side you use the negative 2. So this is going to be x is equal to 1 or x is equal to 5. So 1 or 5. Let's check it out. Logically, it's going to be 5 because the graphs meet here. Clearly, x value there is a 1. And then the graphs meet here. Clearly, x value there is a 5. So the x value here, we know it's a 5. The y value, we can just work it out using one of the two equations, ideally the easier one. The one y is equal to x plus 1. So x, we can put it as 1. Y value is a 2. Does that make sense? Nope. Nope, it doesn't. Because if the x value here is a 3, y value here is a 5, yes, but then this has to be, no, the x value is a 5. I put a 1. Why did I put a 1 in this equation? That's just very, very strange. Putting a 5. So the y value is a 6. That definitely makes sense. Therefore, A is 5, coordinate 6. Yeah, that makes sense because this is all telling us that the x value is always 1 higher than the The y value is just 1 higher than the x based on the equation of the straight line anyways. So that's pretty easy. For 2 marks, this question looks very strange, but it says a single transformation is applied to f to obtain a new graph. A single transformation is applied to f to obtain a new graph defined as h is equal to this. They said here, a with an apostrophe is the image of a under this transformation. Calculate the length of AA. So looks like an easy question also. It's 2 marks. Just have to work out the distance of a line. Doesn't look very crazy, but when I read it for the first time, honestly speaking, I wasn't paying attention. So let's see. A single transformation is applied to f to obtain a new graph as defined as this. Okay, so the original graph of f looks like this. X minus 3 plus 4. Right? The new graph, it looks as though they I would say it looks like they reflected it about the y-axis, because if you reflect this graph about the y-axis, right? Firstly, let's just write down the equation of h. They said negative 4 x plus 3 plus 4. So the y asymptote remains the same, right? It's going to be, oh snap, no, they reflected it about the y asymptote, because the asymptote looks like it's still a 4, right? But then, what? No, wait a minute. So the one asymptote is a 4. Let me just draw it in yellow, maybe, or orange. And then no, that's not the y asymptote, my guy. The y asymptote is still a 4, right? So let's do that. The x, however, is now a negative 3. So somewhere there. And then this is now a negative. So it means that plus and plus, minus and minus. So to get a negative, it'll be a curve here and a curve there, where plus and minus are mixing, plus and minus are mixing. So you have a curve over here somewhere, and then you have a curve over here somewhere. Let me put that in like a very different color, like green. There and there. Okay, so that's the picture of H, right? So they said, logically speaking, this was a reflection about the y-axis. So meaning if this is A, which is 5 coordinate 6, a reflection about the y-axis, the distance here is 5. So the new y will be somewhere here. The x value will be negative 5. Y will still be a 6. So the distance is 10. Not very difficult to comprehend there. Let's go to 10 units. You see, you can write coordinate of A is negative 5 and 6. And the image of A was 5 and 6. Too straightforward. That's question 4. Nothing much to it. We can move on to question 3. Question number 3. It's a quadratic question. It's a quadratic sequence question. They said given the quadratic sequence, right? For 3 marks, show that the general term is given by this. Questions like these, no one should ever lose marks because it just doesn't make any sense. You know, you write down the equation, you get the first difference. 5 minus 6 is negative 1. 6 minus 9, that's negative 3. 9 minus 14, that's negative 5. And then negative 1 minus negative 3. So negative 1, technically you'll be saying plus 3, that's a 2. Negative 3 plus 5, that's also a 2. And then what you do is, starting from the very bottom, you make this equal to 2a. This is equal to 3a plus b. This is equal to a plus b plus c. So 2a is equal to 2. Divide both sides by 2. A is a 1. 3a plus b. If you work out a here, or you put a in its place rather, b is negative 5 minus 3, which is negative 8. And then here you're going to put a plus b plus c equal to 14. A you have, it's 1. B is negative 8. C, this is 1 minus 8, right? So that's minus 7. Take it to the other side, you'll be adding. So C is 21, which is exactly what you clearly have there, right? Therefore, you know that Tn is equal to An squared plus Bn plus C. A, you know it's a 1, you worked it out. B, you know it's negative 8, you worked it out. C, you have 21, you worked it out. Very easy marks. 3.2 says two consecutive terms of the quadratic sequence have a difference of 33. Calculate the value of the larger term. So what they mean is, in the original sequence, right, the first difference is 33 here. You don't know what term this is, but then this is the term after it. Okay, fine. Determine the value of the larger term. So as you see, I've written it, right? You can make n a 1 in the ones. You have to remember that n is any term. This could be term number 10. This would be term number 11. So essentially, the way you're going to work this out is, in the general, it's a 3-mark question, so we don't want to overthink it, as I was just about to. I was definitely about to overthink it. But without overthinking it, let me maybe add an extra layer to this question, right? What we know is this would be Tn plus 2. We don't know what this number would be, but what we know is that the common difference is a 2. And judging from our sequence of first differences here, right, these numbers were getting bigger and bigger and bigger and bigger and bigger. So it means from one number to the other, we were adding a 2, you see? So from 33 to the next number here, would have added a 2, so this would be 35. Now what? Well, yeah. So for the sake of me trying to not overthink this question, let me maybe write down my general term so that I have it in front of me. The reason why I'm deciding to write down my general term is because our general term can give us a lot of information, you know? If you throw in n, it'll give you something. So what we do know is our sequence of first differences, right? This is a arithmetic sequence. So logically, what we know is that 33 and 35 are part of this sequence here. So let's get a general term for this sequence, right? It doesn't even look like we're going to need the general term here. Maybe not. Let's just leave it for now. So what we know is, in this sequence of first differences, our common difference is 2. Our a value is negative 5. Let's just find out the position of 33. It will help us work our way upwards. So in an arithmetic sequence, Tn is equal to a plus n minus 1 d. A is negative 5. And we don't know. D is 2. Tn 33. Let's see the position of 33, right? So we have negative 5 here plus 2n. minus 2, and then 33. 2n minus 7 is what we have there, and then negative 7 goes to the other side. That's going to be 2n is equal to 40. Divide both sides by 2, n is going to be equal to 20. Okay, fine. So all this being said, right, you know that this is in position 20. So if you use your logic, right, look at this. If you look at it nicely, right, let me use the pen red. The term in position 1, right, and the term in position 2. The difference between these two, right, is term number 1 for the sequence of first differences. Term number 3 and 2 produce term number 2 in the sequence of first differences. Term number 4 and 3 produce term number 3 in the sequence of first differences. Fine. So logically, if this is 33 and you have gotten it in position number 20, right, it means that this is T20 and this is T21. So you can say here, calculate the value of the larger term. Let's say the two consecutive terms in the quadratic sequence are given by 33. Calculate the value of the larger term. So, I feel like I took the long way to work out this question. T21, let's just work it out. T21 in the quadratic formula, you're going to have 21 squared. 21 here plus 21. So depending on whatever method you maybe would think of using here, I would really like to think there are other methods that might be shorter. But this is the first thing that came to mind, and for the sake of maybe not wasting time, I just went with it. But maybe if you look at this question a bit longer, you would see that there's another shorter way to do it. So T21 is equal to 294. You can say here, therefore, larger term is 294. If I read the question again, two consecutive terms of the quadratic sequence have a difference of 33. Calculate the value of the larger term. Yeah. So I don't know if this was a 3-mark question or maybe I just did it the long way, but that's a correct answer in my opinion. Question 3.3. 3.3 is quite an interesting question. It's a 3-mark question and it's easy to overhype it. But anyways, it says, excuse me, the value of m is added to each term in the quadratic sequence. Determine the value of m for which only the terms between 1 and 7 of the quadratic sequence will be negative values. So that will be term number 2, 3, 4, 5, and 6. They say determine the value of m for which those terms will be negative values. The one thing you want to recognize with all quadratic number patterns is that they are parabolic, you know? So just thinking of the general term, right? N squared minus 8n plus 21. This is our general term. Take into account that this general term draws a smiling parabola. Apart from it drawing a smiling parabola, let's actually draw it relative to a Cartesian plane before we answer our question. If you think of a Cartesian plane, logically, since we're starting from 1, right? It means that your image will have, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, going on and on and on. So since this is 1, let's put 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So what we know, excuse me, is that at 1, you have a y value of like 14, right there. And then it's 9, 6, 5, going on and on and on. So at some point, the graph is going to turn. Let's see where that turning point is. To get the turning point, we can use this formula, minus b over 2a. This will give us the middle of our parabola, right? So minus b over 2a. This is 8 divided by 2, that's a 4. So somewhere at 4, right? That's where our graph turns. So we can even maybe check for the specific y value where it turns. So we can see here t number 4. This is where our graph turns, right? 4 squared minus 8, 4 plus 21. What you want to recognize is that with all this that we're doing, just because we're looking at this question and the way they've asked it, we're almost forgetting that this is a sequence, is a series question, and we're actually looking at it as more of like a functions question. So what this is telling us is that this graph is a turning point at 4 coordinate 5. So that's like somewhere there. So we know it like comes down, it turns, and then it goes back up. Fine. So this is what our image looks like, whether we like it or not. What we know is that at 1, this is a y value of 14. Out of curiosity, let's check the y value at 7, right? So t7, that's 7 squared minus 8, 7 plus 21. All this in the calculator. 7 squared minus 8 times 7 plus 21. So it's not a coincidence that this is giving us 14 as well. Okay. So what we know is that at 1, the y value is 14, and then at 7, the y value is also 14. You see? So with this image easily in our faces and all that, the question makes better sense, because if you see here, calculate the value of m. It says the value of m is added to each term in the quadratic sequence. So if they're adding m to each term, it means they're moving the graph either up or down. You see, they're just trying to say that the graph is being moved up or down. So you're moving the graph, right? Determine the value of m for which only the terms between 1 and 7 of the quadratic sequence will have negative values. So if you look at terms between 1 and 7, right, originally you have like 9, 6, and then, yeah, it's 9, 6, and then 5, then 9 again, and then 6, because this is parabolic. So the values here will be the same as on the other side there. We know that because of the sequence, you see. They're going down until 5. You see, 14, 9, 6, 5, and then they go up again, 6, 9, and then 14. And then obviously they keep going higher if we're looking at it from that side, going on and on and on. So they said, how many units does the graph have to be moved for these values here to be negative? So it's just asking us how many units do we have to move the graph downwards for this section here to be negative numbers. So the first thing we want to recognize is that this is a y value of 9, a y value of 6, y value of 5, 6 again, and then 9. So logically, for these numbers to be negative, you have to consider a scenario where they are moved down at least 9 units, you see, because minimum of 9 units will all of them be negative, you see. So you're going to have to say here m has to be, so if it's going to be 9 units downwards, it means that m has to be smaller than -9, because the moment you move it 9 units downwards, exactly 9 units downwards, all these other ones will be below 0. But then specifically this will not be below 0. So we have to move it more than 9 units. That's what we're saying here. M is smaller than -9. And then obviously for them to be the only ones below the x-axis, right? We need to make sure that we don't take them any lower than 14 units, because the moment we move this image lower than 14 units, other terms like the 1 here and the 7 there will also be below 0. But the question is only saying only the terms between 1 and 7. So it's only 2, 3, 4, 5, and 6 that we have to consider. So m has to be below 9, but then m has to be above negative 14. We actually have to say above or equal to negative 14 because specifically at exactly 14 units downwards, all these points will be below 0, and then 1 and 7 will be equal to 0. They won't be below 0, so that's still going to be fine. It's only if they were moved more than 14 units downward, then this and that would also be below 0. So this is what you can put as your answer for 3 marks. Funny enough, you can imagine your 3 marks will literally all just be tick, tick, tick here, because depending on how you got to the answer, that's going to vary. You know, some would have worked it out algebraically, but I think using image, it makes it easier to understand. So I would say this is also level 4-5 question easily. If you are not done with the entire paper, there's no point in looking at a question like this. But that's how you work it out. So let's move on. Question number 2. It's another quadratic. No. It's another sequence and series question. Let's see what we have here. It says, given the arithmetic series, right? 5 plus 7 plus 9, etc. up until 93. Determine the general term of the series. Tn in the form Tn is equal to Pn plus Q. Well, this is very straightforward. This is an arithmetic series, and the general term of an arithmetic series is given as follows, and this is something that you get on your formula sheet. A is the first term. Our common difference here is a 2, and this is just too straightforward. A, that is 5, and we leave it as it is. D is a 2. If we simplify this, we have Tn plus 3. There you go. That's your standard form, easy 2 marks. Another 2 marks, it says the given series represents the number of kilometers that an athlete ran each week in preparation for an ultra marathon. That athlete ran 93 kilometers in the last week of the training program. How long in weeks was the training program? Okay, so it is a 2 mark question, so we can expect it to be straightforward as well. So this is the number of series he ran each week, right? So if we find out the number of terms in the series here, then we'll find out which week it was when he ran 93. So in our general term, we can just put 93 where Tn is, and then solve for n. This is giving us 90, divide both sides by 2, n is 45. Therefore, 45 weeks. Straightforward. 3 marks, it says the athlete used this opportunity to raise funds for her high school. Brilliant. And then it says here, the community sponsored her 10 Rand each kilometer during the training program. Calculate the total amount that the athlete raised for her school. So we're going to have to work out the total number of kilometers and then multiply that by 10. So we have to work out the sum of this series. So the sum of any arithmetic series, we have this formula, which is on our formula sheet, or there's another version, but this formula is fine. You can just throw in everything as we see it. And then just make sure that your brackets are labeled properly. You see, because when it comes to this type of a question and putting numbers into your calculator, the only time you're going to find yourself having answers that look funny or something that does not look like it is correct is if you don't use your brackets properly. But judging from what I wrote, I can safely say that I wrote down everything properly and everything was also put nicely in brackets. So this is giving us a total of 2,205 kilometers, right? So here we're going to say, therefore, total raised is going to be, yay, the I comes first, my guy. Total raised is 10 multiplied by 2205, which is equal to 22050. So just over 22,000. Not bad. 2.2 says the general term of a geometric sequence is given by this. Write down the first term. Okay, that's very straightforward. Where n is, we're just going to put a 1. And then this is 2 to the power of 3, which is 8. The sequence in series section here looks too basic. It's almost sad. So to get the common ratio here, let's work out the second term so that we can then get r. This is 2 times 2 times 2 times 2, which is 16. So therefore, r is equal to t2 over t1, which is 16 over 2. No, 16 over 8, my guy, which is a 2. Okay, that's r. Calculate the 20th term. Yeah, this is shockingly too simple. Like, it's almost scary. Write down as a power of 4. Or write down the answer as a power of 4. Write your answer as a power of 4. So it means, okay, so it has to be something. Well, the question here is, are we going to say something to the power of 4? Or are we going to say 4 to the power of something? Write your answer as a power of 4. So 4 has to be the exponent. I would easily just use trial and error for this type of a question. So this number is approximately, or rather it is equal to 4,194,304, right? So if 4 is the exponent, I'm literally just using trial and error. I'm putting numbers here with the big base and then to the power 4. So right now I'm on 16. I've moved on to 20. And then I'm going to ramp it up to about 50. That's too big. Let me cut it down to maybe 40. Too big. I've cut it down to maybe 30. Too big. No, too small. But then again, is there a way we can just do it mathematically? Yes, there is, because you would say here 4 to the power of, no. You'd say x to the power of 4 is equal to 22 to the power of 22, right? So solving for x here, you would say square root symbol with the 4, square root symbol here with the 4. Then you have here shift square root symbol with the 4, 2 to the power of 22. What? This is not looking normal. But let me try that again. Write 2020. Write your answer as a power of 4. So maybe 4 must be the base. And why is this? Let me try 4 as the base. So this would be x is equal to log 4 and then 2 to the power of 22. Okay, let's try that. Yeah, that's better. So our exponent is not a 4. Our base has to be the 4. Okay, there's a power of 4. Well, just the way it sounds. I think I misread it. But here it means that you're going to say, therefore, 11 to the power of, no, 4 to the power of 11. That's your answer. That's T20. Write it nicely here. That's the first challenging question, or not really, but let's move on. Here it says calculate the sum to infinity. Well, this is still the same sequence. So technically, you should be seeing something that looks like n is equal to 1 and then 1 over 2 to the power of n plus 2. we need to work out the sum to infinity of this. So it's a very straightforward question because sum to infinity already has a formula. A over 1 minus r. A we worked it out to be 8. And then our value of r, we worked it out to be a 2. So this is too basic. It's almost looking wrong because this cannot have a, no, I'm making an error because look, the sum to infinity formula, yes, we should use it, but our a value is not 8 and our r value is not 2 because here we have a new general term, you see? So the first term here is going to be 1 over 2n plus 2, or rather 1 plus, was it 1 plus 2 or, oh yeah, yes it was 1 plus 2, so this is 1 over 8. And then term number 2 would have been 1 over 2 and 2 plus 2, which is 1 over 16. So therefore our value of r would have been 1 over 16 divided by 1 over 8. This would have been a half. See? So with that being said, our sum to infinity would then be 1 over 8 over 1 minus a half. This makes better sense because anytime you have a sum to infinity question, right, your value of r has to be smaller than 1, but it has to be bigger than -1. So all this in the calculator, we're getting the quarter. There you go. 2.2.4 says 4 marks. Consider the first 21 terms of the sequence, right? Fine, we're considering the first 21 terms. Yes, now what? Calculate the sum of the terms in this sequence that are not powers of 4. Wow. Wow. Okay. Well, that's interesting. Let's think of powers of 4. So it's going to be 4 to the power of 1, 4 to the power of 2, 4 to the power of 3, going up until we know that term number 20 specifically is 4 to the power of 11. So what we do know is that if you think of the way our sequence is given, right? Where is it? Here we are. This is our general term and our sequence was, okay. Yeah, so this is our general term, right? The terms in this sequence, let's think about them. It was numbers like 8 going on and on and on. Or rather, the general term is right here. So judging from our general term, T1, T2, T3, T4, going onwards, T20, we know it's definitely a power of 4 because it's 4 to the power of 11. T21, we can check, but it's okay. T21 is somewhere here, and then we have all these other ones here. The first term, we worked it out to be 8. Yes, it's 8. Second term, we worked it out to be 16, 32, 64, going onwards, right? So powers of 4, let's try and see what these numbers look like. So 4 to the power of 1 is just a 4. 4 squared is 16. 4 to the power of 3, that's 4 times 4 times 4, that's 64. So that's quite interesting. Let me just try and see if I can get some kind of a trend here. Let me shrink this so that I use up less space. Shrink this also. There you go. Okay, so let's see a few more, right? 4 to the power of 4. 4 to the power of 4. And then you have 4 to the power 5, 4 to the power 6. Going onwards. 4 to the power 4, that's 256. 4 to the power 5, that's like 10 and 24. Going on and on and on, right? So, what do we notice here? Technically, logically speaking, powers of 4, right? I mean, the logic is you're just multiplying by 4 all the time. You see. However, here you're just multiplying by 2 all the time. You see. So logically, ones that will have powers of 4, we're technically starting with 16, which is term number 2, right? And then times by 4, you're going to get a 64. And then you times by 4 again, you'll get a 256 somewhere. But then that will be term number 6. So what I want you to note is that terms that are in position 2, 4, 6, 8, 10, going on and on and on, those will all be powers of 4. Hence why 20 is also a power of 4. So the question again, consider the first and one terms in the sequence, calculate the sum of the terms in the sequence that are not powers of 4. Okay, so the ones that are not powers of 4. Okay, I wish I'd given myself enough space here because for a former question, I did a terrible job because I didn't even give myself enough space, but there's so much to write, you know? But anyways, hope I know the logic now makes sense, right? So let's create space for what we're going to write down, you see. So with all this being said, if you're going to work out all the terms that are not powers of 4, the sum of the terms in the sequence that are not powers of 4, right? It means that you have to be thinking of a sequence that has these terms here. So you're going to think of a sequence that has 8, 32, and then it jumps 32, right? So it's also going to be a sequence where you're multiplying by 4 all the time, because after 32, the next term you're targeting is T5, right? Which will be 32 times 4. That's like 128. Going on and on and on, you see? This up until technically this number here, which we know is, we don't know what it is, but we know that if you're thinking of terms number 1, 3, 5, up until 21, you have to be careful now. That is, from 1 to 21, that's a total of 21 terms, right? And then if you cut out 2, 4, 6 all the way up until 20, that is not exactly half of 21. You see, because half of 21 is just 10.1, but 11 of these terms are the ones that are in position 1, 3, 5, etc. So here you have 11 terms, right? 11 terms in this particular sequence. So the sum of the first 11 terms in this particular sequence is what we need to work out. You see, n minus 1d. N is 11, a is 8, n is 11. The common difference is just a 4. You see. So all the terms that are not powers of 4, this is the sum of all those terms. 2 times 8 plus 11 minus 1. 4 is the common difference. So this is 308. 308 is your final answer. So let me put a arrow like that there to say that's our final answer. So this is the type of a video where I can safely say you may want to go back to the beginning and you can watch it again, if something was not clear. But that's the answer. Let's move on to the next question. Question number 1. Okay, come a long way. It's better to start from the bottom because at least you start with the difficult questions. I'm not necessarily saying in an exam that's what you should do. I'm just saying for the sake of this video, it made sense to do that. But actually, even in an exam, if you want, by all means, do it like that, especially if your answer sheet is together with the questions. If it works for you, obviously. So for X, 3-mark question, very straightforward. Factors of 10 that give us a 3, it's just 5 and 2. Get a negative 3, it'll be 5, it'll be minus 5 plus 2. Very straightforward question. X is equal to 5 or X is equal to negative 2. Next, correct to 2 decimal places. This is the type of equation where you're going to have to use the quadratic formula. And then let's see here, B is 6. So we have 6 squared here minus 4. A is a 3, C is a 1. Everything was already given in standard form, so you don't have to worry too much about anything, you see. So minus B plus minus B squared minus 4 AC and 2A. There you go. They say correct to 2 decimal places, so this is giving us negative 0.18, or it is giving us so X is equal to this, or X is equal to negative 1.81, or rather 1, 2. Okay, moving on. Use me. Awkward. 3 marks, it says. Solve this, solve for X. This is too straightforward because you can see that the base of 2 there is the one thing that stands out. This 8,704, maybe it will have a base of 2. Who knows? Doesn't matter. So from here, you can take out 2x to the power of x as a common factor. You're going to have 2 to the power 4 here plus 1. And then you can just divide that on both sides. Yay. 8,704 divided by this number here. 2 to the power 4 plus 1 is just 17. Would you believe it? So that being said, you would want to just put this. So x is equal to log the base of the x, and then this value that was on the other side here. So this being done, you have here log 2, and then you have 8,704, 17, right? That's going to give you 9. Very nice looking answer, because even if you test it, 2 to the power of 9 plus 4, the whole thing plus 2 to the power of 9. Yep, it gives you the right hand side, and that's easy 3 marks. No issues there. Question 1 should always be a question where you get 100%. The next question is out of 3. It's an inequality question. So this is very simple because it's already giving you your roots. X is 8 or X is negative 2. What you can also clearly see is that this would have drawn a smiling parabola because the X there, they are both positives. So what you know is that one of your roots, as they have already given you, was -2. The other one was +8. They're asking, where is this graph below or equal to 0? It's below or equal to 0 over here, you see. So that's between where x is an element of -2 up until +8, where both of them are included because they said where is it smaller or equal to 0. The graph is equal to 0 at -2 and at 0 because this represents the x-axis, you see. So at those 2 points, the graph has a y value of 0, you see. And then between -2 and 8, that's a section where it's below 0. So if you give your answer like this is easy, 3 marks. Moving on, solving for x again here. Straightforward. The value that has the square root, you can just put that on its own because the goal there is to square it. But before that, we would want to divide by 3. But actually, no, we don't have to. You just want to be careful that if you're going to square the left side, right, and you square the right side, be careful that you square the 3. 3 squared is 9. And then the square root cancels the square there. You see, so this is something you need to be very comfortable with. So that being said, carrying on from here, let me do it using a method that is a bit, no, let's just carry on. So this is going to be 2 minus x, 2 minus x. And then this is, so remember there's a dot there. So that's how we said when you square root, or when you square rather, the 3 gets squared and then this value here also gets squared. So here carrying on, we have 4 on that side, minus 2x and then minus 2x again. That's going to give you -4. There you go. Here we haven't done anything, but if you want to multiply inside, you're going to get this value. These colors are so nice. Oh well, everything on one side, you're going to have x squared, -4 minus 9. That's going to give you -13. Is it? Yep. And then 4 minus 18, that's going to give you -14. Factors of 14 that give a 13, it's definitely 14 and 1. To get a negative here, this one has to be a negative, this one a plus. So even though I factorized here, when I get these final answers, test them both. Because normally one is not going to work out, especially if your original expression had a square root symbol somewhere. So let's see. Let's test x as 14. So we have 14 there, right? Plus 3 square root of what? Square root of thingy. The 14 is not working out. Let's check the -1. If the -1 doesn't work as well, then it means we made a mistake somewhere. The -1 works, so this is definitely correct. This is something we need to discard. So our answer there is correct. 1.2 is a 6-mark question, right? It says here, a rectangle having sides of y minus 3 meters and x plus 2 meters has a perimeter of 24 meters. And the area of 32 square meters. Calculate the values of x and y. This falls under our sequences and series. No. This falls under our simultaneous equation question. This is too straightforward. Well, it's not that straightforward, but it's actually quite easy because if you draw your rectangle, right, they say sides are given as y minus 3 meters. And then the other one is x plus 2 meters. And then they said it has a perimeter of 24. So they're already telling you that 2 times y minus 3, if you add 2 times x plus 2, this should give you 24. That's what they've told you. They also then said the area is 32 square meters. So what they're telling you there is that y minus 3, if you multiply it by x, plus 2. This should give you 32. Two equations given, right? Equation 1, equation 2. We need to solve them simultaneously. So logically, you want to isolate one of the variables first. Ideally, in this case, this side looks like it's easier to isolate something. You see, it just looks that way. So let's carry on after we've isolated it. Let's see here. Next, we have, what do we have next? Yeah, let's simplify this. So negative 6 plus 4, right? That's going to give you negative 2. So we have 2y plus 2x minus 2, or rather, let's deal with this also. The 24, if it comes over to the other side, calculator time, negative 6 plus 4 minus 24. That's negative 26. The variable that we can isolate here, let me isolate x just as a choice, but either of the two would have been fine. So here this is x is equal to 13 over y if you divide both sides by 2. So if you then take that x and you throw it in the second equation, well, ideally, let's maybe throw it in there after we have maybe simplified, but not necessarily. Let's just throw it the way it is now. So here we'd have y minus 3, and then we have 13 minus y plus 2 equals 32. So these two brackets, we will have 13 plus 2, right? That's 15. And then here, let's see, y times y, that's like 15y, negative y squared, negative 45. And then we're going to have the positive 3y equal to 32, right? Simplifying, what do we then have there? Why did I give myself so little space for these types of questions? Like, that's what happens when you haven't done something for a long time. Tend to mess up. Anyways, let's put everything on one side. If I take everything to the other side, you're going to have 0 is equal to y squared. Maybe make this a bit smaller. And then zoom in. What are we going to have if you take it to the other side? You have 15 plus 3, right? That's 18, but then to the other side it will be minus 18. And then negative 45, when you take it to the other side, you'll be adding the 45. So that's 77. Goodness. It's looking very shady, but the final answer hopefully will help us. Factors of 77, that can give us 18. Yay. 11 and 7, fortunately. So we don't have to use the quadratic formula there. So this is quite, it was quite a consolation to get something that can easily be factorized, you see. So once we have y, our x value, we can easily say, therefore, x is equal to 13 minus 11. So x is a 2, or 13 minus the 7, that would be 6. So we can easily then test this by 1.3. 1.3 is a 3-mark question. At first glance, it looks weird, but let's see. Show that this bracket minus this bracket is divisible by 2 for all real values of m and n. The consolation is that it's a 3-mark question, so we don't overthink it. So I won't lie, when I looked at this question for the first time, I kind of went on a wild goose chase. But the one thing I was missing is that this is the difference of two squares. You see, you have something squared minus something squared. So that's just the difference of two squares, you see. For something squared minus something squared, you can always just have two brackets, one with the square root of the first thing, and then the other one with the square root of the second thing, one with the plus, one with the minus, you see. So that's what we're gonna do, because that's easily how you can work a question out like this. So the difference of two squares, logically, it means you're going to have one big bracket, right? And then another big bracket in this case. So our first big bracket, we need to have the square root of this whole thing here. So that's going to be 1 plus x to the power of m, x to the power of negative n. And let's put a plus in here. And then the square root of this bracket here, which is 1 minus x to the power of m minus x to the power of negative n. There you go. Here, you're going to have this value, 1 plus x to the power of square root of m plus that. And then, since you put a plus in this one, means you have to put a minus in this bracket, you see. So here you're going to have 1 minus x to the power of m minus x to the power of negative n, close bracket. There you go. So all this being done, you can see it works out a bit easier now because it's just basic algebra, you see. This bracket, nothing is going to happen because we can't really do anything there. But the next bracket, though, if you multiply a positive inside, that's going to be plus 1 minus x to the power of m minus x to the power of negative n. In this, nothing is happening in the first bracket. If you multiply negative inside, that's going to be negative 1 here, plus x to the power of m here, and then plus x to the power of negative n there. See? So all this being said, 1 plus 1 here gives us a 2. This and this cancel out. This and this cancel out. So in the first bracket, you just have a 2 left. That's a good thing. The next one, this one and this one cancel out. These are like terms, so you have 2 of that, 2xm. This and this, these are also like terms, so you have another plus 2x to the power of negative n. So this is good enough to say that our number will always be divisible by 2, regardless of what m is, regardless of what n is. Because if you think of the big bracket, right, this big bracket here, logically speaking, right, whatever this big bracket gives you, you're going to multiply it by 2, you see. So it means that your answer will always be divisible by 2. So here you can easily then say, therefore, the expression is divisible by 2 for all real values of m and n. You see, there you go. So that's easy, 3 marks. Easy after you've worked it out, but at first glance, it just seems like a mess, you see. So the point here is that, remember, everything here, whatever you get in this big bracket, you're always going to multiply it by 2 anyway. So the final answer will always be a multiple of 2, meaning it will always be divisible by 2. So mathematically, that's how you work out a question like this. And let's move on.